So let me ask you something. What idea is so powerful, so completely overwhelming that you'd actually stop what you're doing and carve it into a bridge? I mean, literally vandalize a bridge just so you wouldn't forget it?
All right, let's set the scene. It's Dublin, October 16th, 1843. You've got this guy, William Rowan Hamilton. He's Ireland's royal astronomer, a big deal, and he's just on a walk with his wife along the Royal Canal. She's chattering away, but honestly, he can barely hear her. Why? Because an obsession that has consumed him for over a decade is about to explode.
And that's the story we're diving into today. It's really a tale of two Hamiltons, right? You've got this brilliant mind on one side and this really troubled soul on the other. It's about that spark of pure genius, but also the deep, profound struggle that lit the fuse. This is the story of the double life of William Rowan Hamilton.
Okay, so let's get right back to that bridge. Because this moment, it's genuinely one of the most famous eureka moments in the entire history of science.
So he's walking past this thing, Broom Bridge, and he later said it was like an electric circuit just suddenly closed in his mind. Bam! A spark flashes. And in that one single instant, he gets it. The solution to a problem that had been driving him crazy for more than 10 years. He absolutely could not risk losing it. So he pulls out a knife. Yep, a knife, and carves the key to his discovery right there, into the stone. This whole thing just leaves you with two massive questions, right? First, what was this formula? What could possibly be that important? And maybe even more interesting, what kind of decade-long struggle pushes a guy, a respected academic, to literally deface a bridge with math? Well, to get that, we've got to get to know the man himself.
Because before all that struggle, there was the prodigy. And when I say his intellect was extraordinary, that's putting it mildly. The guy was on another level.
I mean, just look at how fast this all happened. At age five, he's already mastered Latin, Greek, and Hebrew. By 15, he's reading the work of the legendary mathematician Laplace and finding errors. And then, get this, at just 21 years old, while he's still a student, an undergrad, they name him Royal Astronomer of Ireland. That just didn't happen. It was completely unheard of.
And look, this wasn't just, oh, this kid has potential. No, this was full-blown recognized genius. The guy he replaced, John Brinkley, said it best. He basically said, I'm not saying this young man will be the first mathematician of his age. I'm saying he is. That's not a prediction. That's a statement of fact, right then and there.
And his genius wasn't just theoretical, scribbling in notebooks. It had real-world impact. In 1832, he's working on the math of light, of optics, and he predicts this really bizarre, never-before-seen phenomenon called conical refraction. He tells a friend, hey, you should try to find this. A few months later, his buddy runs the experiment and, boom, Hamilton was right. This discovery made him a global superstar in science. He was at the absolute top of his game. But even when he's at the peak of his powers, at the height of his fame, this one specific problem starts to gnaw at him, and it would become an obsession that would frustrate him for the next 10 years.
Okay, so here's the deal. Hamilton knew how to use pairs of numbers to describe things in 2D, on a flat plane. The next obvious step was, well, can we use three numbers, triplets, to describe things in 3D space? Seems simple enough. He could add and subtract them, no problem, but multiplication and division, for the life of him, he could not get it to work. And this became his white whale.
And you want to know how all-consuming this was? It became a running joke in his own house. Apparently, every single morning at breakfast, his kids would ask him, well, Papa, can you multiply triplets yet? And every single day, for years, he'd have to say, nope, not today. Now, it's really important to know that this huge professional struggle, it wasn't happening in a vacuum. It was happening right alongside a lifetime of really deep personal turmoil. If you really want to understand the guy who carved up that bridge, you have to understand the private pain he was carrying. So when he was a young man, he met this woman, Catherine Disney, and, well, in his own words, he fell hopelessly in love. But he didn't have the money or status to propose, so she was married off to someone else, a much older man. And that heartbreak, it literally haunted him for his entire life. He did eventually get married to a woman named Helen Bailey, but wow, the contrast is just jarring. He told a friend she was not at all brilliant, and by all accounts, their marriage was really tough, really distant, pretty much right from the start. So when you put it all together, you've just got this perfect storm of personal pain, right? There's the lost love he never, ever got over, a difficult marriage, a very real and at times very public battle with alcoholism, and on top of all that, sources say he dealt with bouts of severe depression his whole life, even thinking about suicide, especially after these moments of intense heartbreak. So, okay, picture that guy again, the man walking by the canal. He's not just thinking about math. He is wrestling with a decade of professional failure and a whole lifetime of personal pain. That's the pressure cooker. That's what's building up inside him right before that flash of insight at the bridge. And this was the spark. This is the fundamental equation he frantically carved into the stone. He called them quaternions, and they were the answer. This was the solution to the triplet problem. So here was the big idea, the eureka moment. The answer wasn't 3 numbers, it was 4. He suddenly realized he needed a 4th dimension to make all the math click into place. But, and this is a huge but, to do it, he had to break one of the most basic, fundamental rules of algebra, a rule that had been sacred for centuries. The idea that A times B is always the same as B times A. Well, for his new quaternions, it wasn't. He had just invented a whole new kind of math, the first non-commutative algebra. So Hamilton was convinced he'd just found the keys to the universe, something that would totally revolutionize physics. In fact, he dedicated the rest of his life to working on it. The problem was, the rest of the world wasn't so sure. I mean, Hamilton put his discovery right up there with Newton's invention of calculus. He thought it was that important. But a lot of his peers, they pushed back, and hard. You had the powerhouse physicist Lord Kelvin calling them an unmixed evil. Others were a bit kinder, saying they were beautiful but kind of useless. Like having a fancy pocket map that you had to completely change into something else before you could actually read it. And yet, despite all that debate, all the criticism, his genius was just undeniable. Think about this. In 1865, right before he died, the brand new U.S. National Academy of Sciences was formed. They had to choose their very first foreign member out of all the scientists in the entire world. And who did they pick? They picked one man, William Rowan Hamilton. So that really leaves us with the big question about his legacy, doesn't it? Was Hamilton this tragic genius, a man whose incredible personal struggles led him to a mathematical dead end, something beautiful but ultimately not that useful? Or was that spark on the canal something else entirely? Was he a visionary so far ahead of his time that the world is only now, today, catching up to his ideas in things like computer graphics and modern robotics? That question, I think, is his legacy.